Welcome to STEM Space at Home. I'm your host, mechanical engineer Aspen Meineke. Today's video is all about powering life on the moon. We will first talk with a very exciting guest, a NASA engineer who works in mission planning, and then you will learn how to harness the power of the sun to light up a tower. So let's get started. The phrase, "Houston, we have a problem." Ever wonder who astronauts are talking to? NASA's Mission Control is located in Houston, Texas, in a facility called Johnson Space Center. From here, they support astronauts traveling in space or living in the International Space Station. Johnson Space Center is also where astronauts receive training to prepare for a mission to space. To learn more about NASA's Johnson Space Center and what it's like to be a NASA engineer, I want to welcome my friend Clark Esty.
Hi, Aspen. Thanks for having me. Hi, everyone else. My name is Clark Esty, and I work for NASA's Johnson Space Center as a systems integration engineer. So within NASA JSC, I work within the Exploration and Mission Planning Office, and my team largely focuses on mission design, from inception all the way through flight. I specifically work on mission design for the Artemis III mission, which is the mission to get humans back to the surface of the moon in 2020.
That must be so exciting to work at NASA. Can you tell us a little bit more about the Artemis III mission and your part in it?
Yeah, so the Artemis campaign is NASA's bold goal of getting humans back to the surface of the moon and establishing a permanent presence there. So my job largely focuses on Artemis III, which will be the first flight of the Human Landing System, or HLS, to put humans back on the surface of the moon. Now, planning a mission to the moon is a huge undertaking and involves a huge amount of people. So in addition to designing and building the vehicles, we have to make sure that the crew has everything that they need in order to survive the mission. And so this workforce is comprised of thousands of people that work at various centers all across the country. And we all have to make sure that we're communicating clearly in order to come together and fly a successful mission come launch day. So once we get to the moon, how do we survive on the moon? I love that question. And I think it's a very difficult technical question, right? Think about living in your house and all of the things that you rely on and take for granted. Now we're going to need those on the moon. So we're going to need air to breathe. We're going to need water to drink. We're going to need food to eat. But importantly, we're going to need power. And we're going to need power to keep all of our life support systems online, to be able to ensure that we have the proper climate, to offer lighting for the crew to see. And one of the very important ways that we get that power on the moon is through solar energy and through solar panels. And this offers us a way to get renewable energy such that we can gather the sun's energy to support the crew and store excess energy in batteries in case we have any times where we're not able to gather energy from the sun. So this is a lot easier than carrying all of the batteries that we need with us, because batteries weigh a tremendous amount. I know that you'll be working on solar panels today, and so enjoy, and just keep in mind that not only on the surface of the moon, but even on our transits out to the moon and back from the moon, solar energy and solar panels are a very critical piece in keeping our crew alive on these missions.
Thank you for joining us today, Clark. We really enjoyed having you. All right, students, let's jump into today's mission. Like Clark mentioned, power is essential when living on the moon. Solar panels are a great way to keep life support systems online, provide a breathable and comfortable climate indoors, and even to keep the lights on. But what exactly are solar panels? Solar panels are devices that convert sunlight into electricity. A solar panel, just like the one I have here today, is made up of solar cells, and each cell is made up of a small disc of a semiconductor, like silicon, and is attached by a wire to a circuit. As light strikes the semiconductor, light is converted into electricity that flows through the circuit, and then as soon as the light is removed, the solar panel stops producing power and can use electricity that the solar panel has stored. So let's hear from electrical engineer Jeremiah McNatt on how NASA already uses solar panels in space.
A solar panel is a collection of solar cells strung together with wires in a way to produce a certain voltage and current to make a certain amount of power for whatever application you're going to need it for. Probably the most well-known use of solar panels in space is the International Space Station. You can see on this model, the space station has a series of solar arrays. These arrays are what powers the station. They are made up of panels like this. You can see all the individual cells have been connected in such a way to produce the proper amount of power needed to run the station. Each one of these cells is around 15% efficient. So here at NASA Glenn, we focus on the high efficiency solar cell devices. We do that with this system here. Our reactions occur inside this chamber. We'll take substrates, something like this 2-inch wafer, load them up inside a platform in this chamber. We then use the remote controls to transfer them into our system. We can come over here to the computer where we will load up a recipe. The best advice I can give to somebody who wants to be an engineer at NASA is to always keep tinkering with things and finding out how things work.
Your mission today is to build a welcome tower for your lunar base that also has a light up sign powered by the sun. For this activity, you're going to need tape, scissors, a ruler, 3 5-ounce paper cups, 3 sheets of paper, 1 paper plate, 7 bendy straws, 1 LED light, and 1 solar panel. Also, if you don't have a solar panel available to you for this activity, don't worry, you can also use a coin cell battery that can be found at many grocery stores that uses a 2 to 3.3 volts battery. First, let's make a welcome sign. So cut out 1 sheet of paper to be 2 inches by 2 inches or 5 centimeters by 5 centimeters. Another option is to use an index card for your sign. On your sign, write the name of your lunar base. Mine is Starry Settlement. Fun fact, did you know a day on the moon lasts 29.5 Earth days? This means if you live on the moon, you will experience 2 weeks of sunlight followed by 2 weeks of complete darkness. To help our astronauts make their way back to the base at night, we want to light up our sign. We will use a solar panel and our LED light to do so. Let me take you outside so I can show you how to connect your LED to your solar panel. Outside today, and I'm going to show you how to power your LED with your solar panel. As you can see, when you look closely at your LED, that one side is longer than the other, and that's exactly how it's supposed to be. The longer side designates the positive end, and the shorter side designates the negative end. And then when you look at your solar panel, the red wire shows that it's a positive current, and the black wire shows that it's a negative current. So now I'm going to show you how to connect your LED to your solar panel. So you're going to use these alligator clips, and if you squeeze the ends, they will open up like that. And so we're going to connect the longer end of our LED, which is the positive end, to the red wire, which designates the positive current. And then we're going to connect the black wire to the shorter side of the LED. And as you can see, it lights up. And so if I pull it into the shade, you can see it a little better. And there you go. Now that we've attached our light, we want to raise our sign so astronauts can see it when exploring the moon. Your challenge today is to raise this sign at least 1 foot or 30 centimeters off the ground. Another important thing to consider is how we power the light. As I mentioned, the solar power works by being exposed to the sun. This means our solar panel must have full exposure to the sunlight at all times. But the sun doesn't always stay in the same place, right? So think about how you can rotate the solar panel to face different directions depending on the location of the sun. Okay, let's recap. Your mission is to design a welcome tower powered by the sun. Our design constraints is that the sun includes the name of your base, the sign has an LED attached to it somehow, the sign must be raised at least 1 foot or 30 centimeters, and this will be measured from the bottom of the sign, but you can always go higher. And then the solar panel must also have full exposure to the sun. We recommend that the base is a paper plate to help you stabilize the tower. And then you get a bonus if you allow the solar panel to face different directions depending on the location of the sun. So what I mean by this is that if you have your solar panel and the sun is shining directly down on it, and then let's say the sun starts moving towards the camera here, I need my solar panel to still tilt this way so that it can follow the direction of the sun. So think about how you can get this flat solar panel to somehow turn different directions. As you get started, don't forget to use the engineering design process. The first step is to brainstorm your design. So go ahead, grab a sheet of paper, and think of what you want your lunar base to be called, where you want your LED placed on your sign, and then how you're going to build a tower to hold up the sign and the solar panel in a way that allows the solar panel to rotate different directions. Once you decide on a design, go ahead, build it, and then test it by seeing if the LED lights up and if the solar panel can rotate to different degrees. Again, if it doesn't work the first time, that's okay. Just think about how you can adjust your design and then redesign it and try again. I cannot wait to see all of your designs, and don't forget to share on social media using #StemSpaceAtHome. Thanks for watching, and I'll see you in the next video.